Okay, welcome back to the first video that I've filmed for about a year now. It's been a while, hasn't it? But we're back, we're doing some Hack the Box machines. I've actually done two recently, which I'll record videos for very soon. Obviously can't release them until the machines have been retired, but yeah, they are waiting to be done. And I've also submitted my own Hack the Box machine recently, so you guys can hopefully enjoy playing that soon. Now in this video we're going to take a look at Kerberos silver ticket attacks, as you probably guessed from the title. And I guess the first thing to say is that if you don't know much about Kerberos at all, you don't really know what it does, what it's for, how it works, I would strongly recommend you go and watch my previous video on just Kerberos in general. Now it is a very long video, you don't have to watch all of it, but just at least watch some of it until you get a basic idea of how Kerberos works. There's no point me kind of rehashing everything in this video when I've already done a video like that I put a lot of time and effort into to try and explain things clearly. So yeah, there's no point in doing that again in a worse way here. So assuming you have got some understanding of Kerberos, let's bring up a diagram from that old video and we'll kind of explain the difference between a silver ticket and a golden ticket and what we're going to be doing. Again, I'm not going to go through things in too much detail, but real quick summary. We get a TGT in this first part here, in this initial logon, and then we use that TGT to request a service ticket, and then we use the service ticket to authenticate with the service. In this case, SQL server. We're going to use that as our example service again because it's a fairly common service and it supports Kerberos authentication. Again, I've already done a video on golden tickets, but as a quick summary of those, for a golden ticket, we get the password of the KRB TGT account, which is a special account in every domain that is responsible for encrypting this first part, this initial logon part. And it's basically a way of proving that the ticket is legitimate. So if we get the password for that account, we can just create our own fake tickets that say we're a member of domain admins or whatever we want. And that's why a golden ticket is great, because it means you can then use that to authenticate to any service. In this example, we've chosen SQL, but with the golden ticket, it could be literally any service. And that's basically the difference between a golden ticket and a silver ticket, is that the silver ticket is only going to let us pretend we're domain admin to one specific service. Again, in this case, SQL. Whereas the golden ticket, we could use that to authenticate with SMB shares, PowerShell remoting, pretty much anything that supports Kerberos authentication on any machine in the entire domain. So that's why a golden ticket is very valuable. But in the real world, a lot less likely that you're going to be able to get a golden ticket, whereas a silver ticket is much more realistic. So yeah, the golden ticket basically lets us skip step 1 and 2 of getting a valid TGT, which is then used to request all the service tickets, whereas the silver ticket is letting us skip step 3 and 4. So yeah, instead of getting a service ticket from the domain controller, we're going to just create a fake one ourselves, and then we can skip straight to step 5 and just send that to the SQL service. And the reason we're going to be able to do that is because we're going to get the password for the SQL service account. So that's kind of the key that makes this all work, is that we need to be able to get the password for the account that's running the service that we want to perform the silver ticket attack against. So let's do a quick demonstration of this. And the first thing I'm going to do is set up a user account for the SQL service to make it vulnerable. So I've not done this in advance because I want you guys to see exactly what actually makes an account vulnerable for this. So we'll create a new user, we'll just call it SQL user. SQL user, that's going to be his username. The password we'll just set to password with a 0, something that's just going to be easy and quick for us to crack. And we'll have that user account there. So now we just need to set this to actually run the SQL service. And this is again what kind of makes it vulnerable. So if we look for SQL server in here, there it is. We'll see that at the moment it's running as this virtual service account, which is not vulnerable. But if we set it to run as our SQL user, and we'll put his password in, it should grant us, yeah, it grants us the logon as a service permission. Cool. And then we restart service, and it should be all happy. Cool. So that's now running as that account. But as it stands, this is not vulnerable to any kind of attack because at the moment this SQL user does not support Kerberos authentication. So if we actually tried to authenticate with SQL using Kerberos, it wouldn't work right now because, and again you kind of need to watch the previous in-depth explanation on Kerberos stuff to understand this, but it's going to need a service principal name. And this is basically how the domain controller is going to understand that this account is the one that's running the SQL service on this machine. So when an SQL client connects to the server, it will specify an SPN, and it needs to match what we put in here basically for this account to end up getting used for that Kerberos authentication. So let's have a quick look at the Microsoft documentation, and it says these are all the different syntaxes for the SQL service, the SPNs on it. And I think the one that we're going to use is probably this, because if I remember rightly, the SQL client that we're going to use to demonstrate this does actually specify the port as well. So basically we'll just copy that, put it in here, and then replace everything that we want. So this is the machine name, followed by the domain name, and then the port, which is 1433, if I remember rightly, for SQL. So we'll add that, and then that should be enough to make our account vulnerable. And it makes it vulnerable to two things. First of all, it makes it vulnerable to Kerberosing, which again I've done a previous video on, but we will do it now just to get the password. And then it also makes it vulnerable to the silver ticket attack, assuming we've got the password for the account. So let's do, we'll use rubius. You can use inpacket as well, but I just prefer rubius, tends to work a bit better for me. We'll do Kerberos, and then we'll do the domain, which is going to be kerb.local. The cred user, which is going to be the user account we're going to use to connect. And we'll use our test account because, like I said, we need to have just at least some basic credentials. Password is going to be test pwd, and I can't remember what else we need. Is that it? Oh, it needs to have the domain name in it. So kerb.local. There we go. That's all we need. So that does a Kerberosing attack. I'm not going to go into that because, like I say, I've done a previous video on it. I am also going to do no wrap because for some reason the default is to have it wrapped, which means you can't copy and paste it. But we'll copy that hash essentially, and we will use hashcat. So I'm going to do this on my machine instead of the VM because it works a lot better. But we don't actually need to specify the mode anymore. This was a nice tip I picked up from a IPsec video recently. You don't have to specify the mode. You can just paste the hash in. So we'll do that, and then just say the word list that we want to use. So we'll use rocku as usual. And this should very quickly and easily crack that password. And there we go, it's done already. So it's got the password, which was password with a 0. So we'll copy that. And now we've got the password to this service account. So if we go back to our in-depth diagram of the way the Kerberos authentication process works, we'll see that this part here, step 4, where the domain controller sends back a service ticket for the service that we're accessing, you see that it's encrypted with the service account's password, and that's what proves that it's valid. Because when we send it to the server, we can see step 6, it decrypts the ticket using its own password, and that proves that it's legitimate. Because in theory, there's no way that the user, or the attacker in this case, knows the password for the SQL server account. And that's the kind of key that makes this whole silver ticket thing work, is that we've got the password for the SQL service. So we can just bypass step 3 and 4. We don't need to get anything from the domain controller. And in fact, you can do this whole attack, well, not the whole attack, sorry, but you can do this first part of the attack, actually creating the silver ticket, completely offline. You don't need to contact the domain controller at all. So because we've got that password, we can just create our own service ticket that says we're a member of domain admins or says we're the administrator, whatever we want, encrypt it using the server's account's password because we've got that from the Kerberosing attack, and then we can just send that to the SQL server and it will think it's all perfectly legitimate. Now the one exception to this where it won't think it's legitimate is if it does what's called pack validation. Now the pack is the part of the service ticket that contains all the information about who we are, like what our SID is, which groups we're a member of. That's the bit that we're faking to say that we're domain admin. So what happens when it does pack validation is that the SQL server, in this example, would contact the domain controller, send it the ticket that we've supplied and say, can you just check and make sure this is actually legitimate? And in our case, the domain controller will definitely say, no, it's not legitimate. You would think that that would happen all the time, like surely any service that's accepting service tickets should pass them to the domain controller to make sure they're actually legit, but it doesn't. It happens quite rarely. I think off the top of my head, the rule is that if it's running as a service, so if we go back to our domain controller here, if it's basically in this list, if it's running as a Windows service, then it won't do pack validation, which is kind of weird. You would think that these are the things that do need to do it, but yeah. I did find that IIS websites, even though IIS runs as a service in here, it doesn't actually qualify because each website that you run can run as a different user account. And I don't really think it was intentional, but because of the way it handles user accounts for each website, they don't end up running as a service. They run as I think it's a batch job or something it's technically called. So they don't have the service SID, which means they do have to do pack validation, which means if you've got a website running on IIS that supports Kerberos authentication, as far as I can tell, you can't use a silver ticket attack against it. I tried disabling pack validation in the registry and stuff like that. Doesn't work for that scenario. As far as I can tell, that's always going to do pack validation. But luckily for us, SQL, we have no such worries. It just runs as a service and that's it. So that's kind of most of the explanation out of the way. Let's get to the fun bit of actually doing this. So we know that the password was password, and this output from Rubius gave us all the information about the username and the MS SQL service SPN, all that stuff. So I'm going to cheat a bit here and use one that I copied and pasted earlier because I can never remember all the syntax for all the commands. Actually, that brings me on to a little shameless plug. I've actually been working on a GUI or a GUI, whatever you want to call it, for rubius because, yeah, I always forget the commands. Like, if we run rubius without anything, you get this help text, which is great, but it's like 500 lines long and has so much stuff in it. Like, I can never... Like this, it's huge. So yeah, I can never remember exactly what commands, and then reading through all that is a pain. Don't get me wrong, it's a great tool. There's loads of amazing stuff in it, but yeah, if you don't use it that often like me, then trying to remember all the commands is a bit annoying. So I'm making a GUI, which I'll show you briefly now. So yeah, this is what it's looking like. At the moment, it's nowhere near finished. So let me just run it and then you get a better idea. So yeah, this is what it kind of looks like. It's essentially just going to pass the correct command line arguments based on what you select. So like for Kerberos, which we did earlier, we could just basically leave all these default settings, just put the domain in here, so that we want to use some alternate credentials, and then click run and it would work. Originally I did want to make it so that it doesn't just pass command line arguments and show you the output of the normal command line version. I wanted to make it a lot nicer, but because of the way Rubius is written, it's not conducive to that, let's just say. Again, don't get me wrong, it's a great tool, massive respect for the people who made it, but yeah, it was written to serve one purpose, which was to be a command line program. It was not made to be kind of reusable in other programs, which is fair enough because all they were making was a command line program. But yeah, this will be released at some point. There's a link to the GitHub, which is this, in the description or the pinned comment. And yeah, hopefully I'll get that finished. I am actually using C# for once as well. I know I'm known for my VB, but yeah, C#, which I've got to say is horrible compared to VB. But yeah, we'll leave it at that. So yeah, keep an eye on that GitHub page, and that will be released fairly soon. But for now, we are stuck with using the command line version. So let's go back to my cheat sheet. The things that we need are the service principal name, which we've already got. We need the NT hash, or the RC4 hash of the SQL service account's password. So let's just get that quickly. We can do that with Rubius, which is nice. Password, and the password that we got from Hashcat was just password with a 0. So we do that, and it gives us the RC4. So we can take that and put that in there. And then we need the SID of the domain, and that's pretty much the only other thing we need. So to get the SID of the domain, there's a lot of different ways you can do this. I'll show you two quickly. One is that I wrote another program that will do this for you, so I'll show you that very quickly. I know this is getting kind of off topic, but it's very simple. This is the entire program, and most of it's help text. But yeah, it literally just binds to the domain, whichever domain you supply in the command line arguments, uses the username and password you supply in the command line arguments, does a search, tells it to include the SID, so that's this object SID here, does a search in the domain for any user account, so it's looking for users that have got a SID. I mean, every user should have a SID, but just in case, users that have got a SID and that aren't from an external domain. I don't think I actually need that bit because I think foreign security principles won't also be user class, but whatever, it's not hurting anything. So yeah, it does that search. If it finds, or it just finds the first user account it can, which is find one, then it just gets the SID from them as a byte array here, and then it just constructs a SID from that byte array, and then uses the account domain part of it, which the .NET security identifier class already has like a built-in way of just getting the domain part, and I'll explain that in a bit more detail here when we do it in the second way. So this is an alternative way, any kind of LDAP connection tool, or searching tool, sorry, will connect to the domain. We will probably have to bind as our user account, or as any user account. Then we can do a search. So if we do a search for just any user, and we tell it to include the object SID attribute, we do run. Now for each user account in the domain, we can see their SID, and basically the domain SID is the part that we need, which is what I mentioned in that VB program. It just gets the domain SID part because we don't need this last part here. If you notice, every user account has got the exact same first part of the SID. So this section here is the same for every user account. But the last part is different, so that's called the RID, the relative ID. We don't want that part, we just want the first part. So we'll copy that, and we'll put that into our command. So SID, there's the domain, and yeah, that's it. We just tell it that we're going to pretend to be administrator. You could put anything you like in there. And we're going to use /ptt to actually store it with our logon session. So that stands for pass the ticket, and that just makes life a lot easier because Windows will just automatically use it now whenever we try and access this service. So we'll do that. I think we've got everything in there. It creates a ticket for us. We don't actually need to do anything here because it successfully imports it to our session. So now if we do klist, which is just a built-in Windows command, you can see we've got this Kerberos ticket saying we are administrator for this domain, but it's only going to work for this service. So let's test that out. If we do SQL CMD again, -s kerbdc1.kerb.local, and we've got to use the fully qualified domain name here. We can't put an IP address here because Kerberos doesn't work with IP addresses by default. And again, the reason for that is because here we've got this service principal name, and that's the only thing that we put in that domain account, if you remember. So that's the only thing that's here. There's no IP address here. So when the client constructs this name and the DC searches for any user account that's got this SPN, it's not going to find one if we put an IP address. So that's why, again, we have to put the fully qualified domain name, because that's what we're entering here. So we'll do that, and it should just let us in. It does. So now if we select which user account we are, we've got an SQL command that we just copied and pasted from Stack Overflow, which will just tell you what user account SQL thinks you're running as, basically. So we'll do that. We'll type go, and you can see it says it thinks we are kerb/administrator, which obviously we're not. So now we've got access to all the SQL databases. It thinks we're the database admin, so we can do things like enable the XP CMD thing, which lets you spawn processes. We can obviously view all the databases. We can do whatever we want within SQL. But again, this is limited to the SQL service. It doesn't mean we've got admin rights on the whole machine. It just means this SQL service thinks we're admin. So obviously the amount of extra information or extra damage or whatever you can do depends massively on what service it is that you get a silver ticket for. Unfortunately, you're probably not going to get a silver ticket for things like SMB shares or PowerShell because they all run as the computer account, and it's very hard to get a computer account's password because they're just like these massively long, complex passwords that get changed every 90 days or something. So in reality, you're probably only ever going to get passwords from actual users that people have set weak passwords on, and that's kind of the thing that makes this all work. Again, I already explained that, but it's the fact that the SQL service account had a password that we could crack. So yeah, if we go back to here where this all started, is because there's a service account that's a user that someone has set a password on, and they've set a weak password. So we can, if you remember from the Kerberos video, we can get this hash for any service account. Literally anything that runs a Kerberos service. We could get this for the domain controller, all the services that runs. Any computer account, all the Kerberos services that runs. But the difference is that we can crack this user account one because somebody set it to a fairly weak password. So the kind of mitigation is to just set a really strong password or use managed service accounts, which are a special kind of user account you can create. Oh yeah, that's right, you can't actually create them in here. I forgot about that. You need to use PowerShell or something to create them. But essentially they're special accounts that live in this folder that will act like a user account. You can use them to run services, but they have the long, complex, automatically changed passwords of a computer account. So they're kind of the best of both worlds to run services. So that's what you should do, is use them and not just use a normal user account that's got a rubbish password. So yeah, hopefully that explains everything. Again, let's just take one last quick look at the diagram to sort of make sure this all made sense. In a normal legitimate scenario for step 3 here, we'd send a request to the domain controller and it would send back a service ticket that's encrypted with the SQL service account's password. And that's how, when it gets to step 6, where the SQL server receives that ticket, it knows it's legitimate, because normally the user would not have the SQL server's password. So it knows that this must have come from the domain controller, because the domain controller and the SQL server should be the only things that know that password. So it's like a shared secret between them. The problem is, as we saw with Kerberos or plenty of other methods, you can get passwords. Like maybe you compromise the actual machine that's running SQL service and you manage to get the password out of memory or something like that. There's lots of different ways you can potentially get passwords for service accounts, because again, often they're not set to really long, complex things. They're just, someone just sets them to like a short, easily rememberable password. And it's also quite often the same for every service account. But yeah, instead of all that legitimate stuff happening, what we're doing is skipping step 3 and 4 because we already know the password. So we just create a fake service ticket that says we're domain admin, and then we send that to the SQL server, and it believes it because it can decrypt it using its own password. Again, if pack validation is required, then that will stop this attack. There must be a setting somewhere to enforce that for every Kerberos request. Obviously, the downside is that it will slow things down, because now for every request the SQL server receives, it's got to do some network communication with a DC and validate it and then get a response back. So it's going to slow things down. I have actually seen people specifically saying they want to disable pack validation for services that do use it just because of that, just to improve performance. But yeah, probably not a good idea. So I think that covers everything. I'll probably remember something after I've filmed this that I should have mentioned, but yeah, hopefully that explains things, and hopefully you can also see why it's it's not as useful as a golden ticket, but it's more realistic. Like a golden ticket, again, we'd have to get the KRB TGT account password, which isn't vulnerable to Kerberos, again, because it's a really long, complex password. So yeah, in the real world, much less likely you're going to get that. So yeah, I think that's it. Let me know if you have any questions in the comments. I'll try and do my best to explain stuff. And yeah, there'll be more videos coming soon.